It's a great morning. Unbelievably good. Hope your morning is superb as well. We're going to look today at a section that requires a lot of discipline and attention to detail. We're going to look at solving equations in which I have variable terms on both the left and the right side of the equation. So, I am going to use the same four steps as I did from section 2-3, so I'm not going to waste your time writing all those up here, reading through them. You can look back to the section 3 notes. The step we kind of bypassed over, didn't need to use on section 3, was moving your variable terms and collecting them, joining them up on one side of the equation, because in section 3, all of the variable terms were on one side of the equation. So step number 2, that's where we got to focus in on today from the 4-step process from section 3, is getting our variable terms together on one side of the equation, and we are going to want to move the smaller variable term first. We'll show that in practice here right now. So first example I have is 7x plus 19 equals negative 2x plus 55. So I'm going to look, step 1 was look to combine like terms, distribute, simplify on either side of the equation. Nothing here, nothing there. X's and numbers are non-like terms. So I see here that I have 7x's on the left side and negative 2x's on the right side. The x term that is smaller in this case is going to be negative 2x. So I'm going to use inverse operations and add 2x to both sides. So what that's going to do is get rid of, cancel out my x's on the right side. Negative 2 plus 2 is 0. Left side, 7 plus 2, 9x plus 19 will equal double nickel. Double nickel, that's 55. I'll get the 9x term alone here. I'll move my numerical values to the other side of the equation. Subtract 19 from both sides. 9x will equal 55 minus 19 is 36. And then last step, to get x alone, I'll undo multiplying it by 9 with dividing both sides by 9. 9 divided by 9 is 1, so I have 1x equals 36 divided by 9 is 4. So there is my final answer. So this is exactly what I'm looking for, showing inverse operations all the way down to get you the final answer. Again, for full credit, I need to see all these steps to show me that you understand the process of inverse operations. Please and thank you. Example 2, again, nothing to clean up on the left or the right side. So I'm going to move my smaller y term. So be careful, this is where we need to get into what is smaller. Negative 9y, positive 6y. What we mean by smaller is the term that is furthest to the left on our real number line. So negative 9 is further left than positive 6. So you might want to think which value is colder. 9 below is colder than 6 above. We don't need to see 9 below for a temperature anytime soon. Let's keep those temperatures away. So I'm going to add 9y to both sides. Negative 9 plus 9 make 0. So I've got 90 equals 6 plus 9, 15y. And then last step, to get y alone, I'm going to undo multiplying by 15. So I'll divide both sides by 15. Y will equal 90 divided by 15 is 6. Okay, examples 3 and 4 are a little more challenging because there is some cleanup to do on both the left and right sides of my equations. Example 3, I have like terms here on the left side of the equal sign. I have 5x take away 3x, so that'll leave me with 5 minus 3, 2x, plus 4 will equal, on the right side I have 2x and 1x, that'll leave me with 3x plus 8. I'm going to get my x terms gathered up, collected on one side of the equation. I'm going to move the smaller 2 or 3. Yes, 2 is smaller, so I'll subtract 2x from both sides. 2 minus 2, 0, plus 4. I've got 4 equals 3 minus 2, 1x plus 8. I'll get the numerical terms to the other side of the equation. Minus 8, minus 8. 4 minus 8, negative 4 will be my x value. Boy, if you're happy and you know it, clap your hands. I sure am. This is great. All right. Example 4, I've got a distributive property to take care of on both the left and the right side of the equation. So I'm going to multiply my 4 outside in. 4 times 1 is 4. 4 times negative 1x is negative 4x plus 3x will equal negative 2 times x, negative 2x, negative 2 times 1, negative 2. Left side I can put together negative 4 and 3, negative 1x will equal negative 2x minus 2. I'm going to move the smaller x, careful, negative 1 or negative 2. Remember, we're looking for the colder, so negative 2 is colder than negative 1. I'm going to have 4, and then negative 1 plus 2 is just 1x will equal negative 2. Last step to get x alone is subtract 4 from both sides. I've got x equals negative 2 minus 4 is negative 6. Hooray! We'll be back with the remainder of the examples. Okay, we're back for the next 4 examples here. Example 5, I have this distributive property operation again. So I've got 1/2 times b, 1/2 b, and then half times 6. Half of 6 is 3. That's going to equal 3 over 2 b minus 1. So I've got some fraction action here, no problem. I'm going to move the smaller fractional b, so I'll subtract 1/2 b from both sides. Nice thing about my fractions here, 3 over 2 and 1 over 2 have common denominators. So I'll have 3 equals 3 over 2 minus 1 over 2 is 2 over 2. And of course, 2 over 2 is just 1. So I'm going to have 3 equals 1b minus 1. And I got this single b here by taking 2 divided by 2, which is 1, 1b, or just b. Add 1 to both sides, 3 and 1, 4 is my b value. In example 6, we have some decimals. 0.5 plus 0.3y equals 0.7y minus 0.3, so my smaller y is 0.3y, so I'll subtract it from both sides. 0.5 will equal 0.4y minus 0.3. Add 0.3 to both sides. 0.5 and 0.3 is 0.8. Will equal 0.4y. I'll undo multiplying by 0.4 with dividing both sides by 0.4. 0.8 divided by 0.4 is 2. So I'll have 2 equals y. Good times, great oldies. Hey, the kind of a big topic today are special cases of equations with variables on both sides. So there are 2 scenarios in which your variable terms are going to cancel out. They're going to disappear. And you're going to be left with one of 2 scenarios. Let me walk through these 2 scenarios here. First scenario, I'll distribute 3x is 3 times x, 3 times 2 is 6. So 3x plus 6 equals 3x plus 4. Here, you're going to move your smaller x term. Whoa, 3x, 3x, they're the same. So it doesn't matter which one you move. Subtract 3x from both sides. Your x terms cancel out on both the left and the right side of the equation. So you've got 6 equals 4. So when your variables cancel out, you're going to be left with either a true statement or a false statement. In this case, you're checking, is 6 equal to 4? Absolutely not. 6 and 4 are not the same number. So in this case, 6 equals 4 is a false statement. When you get a false statement after your variables cancel out, there is no real solution. There is no number that you can plug in for your variable, in this case x, that will make the left and the right side equal. Not possible. The other case, if I distribute here, I've got 2x plus 8 equals 2x plus 8. I'll move the smaller x. Oh, they're the same. So that'll indicate to you when they're the same. They will cancel out. 2x minus 2x is 0. 0 plus 8 is 8. 0 plus 8 is 8. So in this case, we have a statement, 8 equals 8, that is true. So since we have a true statement, this tells us that all real numbers are solutions. You can plug in any number you want for x, and the left side and right side will be equal. Let's show you one. Let's pick 5, easy number. 5 plus 4 is 9. 2 times 9 is 18. Let's plug in 5 for x. 2 times 5 is 10. 10 plus 8, 18. So you got 18 equals 18. Try it for another number if you'd like. Any number will work. So we'll write this as all real numbers. So those are your special cases. We'll be back to look at some word problems and geometry connections. All right, the final 4 here kind of reminds me of college basketball. I hope there's a good season this year. Final 4. We have some literal equations here. We're going to work on some word problems where we write down exactly what we read word for word. So first example says twice the sum of a number and 3. So I'm going to take 2 times a number and 3 added together. So that's going to look like 2 times the sum of a number and 3. So 2 times the quantity of x plus 3 is equal to, okay, equals 4 times the number decreased by 20. So 4x decreased by 20. So the setup is probably the most challenging. I'll distribute 2 times x, 2x. 2 times 3 is 6. That'll equal 4x minus 20. I'm going to move the smaller x here, subtract 2x from both sides. Be left with 6 equals 4 minus 2, 2x minus 20. Add 20 to both sides. 6 and 20 is 26. Will equal 2x. Last step to undo multiplying x by 2, I'll divide both sides by 2. 1x will equal 13. What a beautiful thing. All right, last literal equation example here. 2 less than 2 times a number. Well, to take 2 less than 2 times a number, I need to subtract 2 from 2x. So this is 2 less than 2 times a number. Is the same as, so that'll equal the number plus 64. So 2x minus 2 will equal x plus 64. Again, we're going to have a lot more practice with these here in the coming days and weeks ahead. So I'll move the smaller, the colder x, subtract x from both sides. 2 minus 1, 1x minus 2 will equal x minus x is 0, 64. Add 2 to both sides, and 1x x will equal 64 plus 2, 66. Lovely. My last two examples are perimeter calculations. You are going to be given all side lengths except one, but then you are going to be given the perimeter, which is the distance of the side lengths going around the outside of the figure. So I'm going to add my three side lengths together, 6 plus 8 plus, I don't know, they need to add up to 24. So 6 and 8, 14, plus x is 24. Undo adding 14 with subtracting 14 from both sides. 24 minus 14 is 10 inches. And you can always double check. 6 plus 8, 14. 14 plus 10 is 24. Last figure here, we've got some meters. We've got 5 plus 12 plus 14 plus, I don't know, has to make a total of 39 meters. So when I add the three known sides together, 5 plus 12, 17, 17 and 14 is 31, plus x will equal 39. Subtract 31 from both sides, and I'll get that missing side length here. The right side is 39 minus 31 is 8 meters. All right, there we have it, 2 4 notes. Stick a fork in it. It is done.